All right. So DevSecOps. So we've spent some time talking about where we've been. We've talked about some practices that we've done in the past. So let's talk about and think about where we're at today and where we're going from as a nation. Okay, and what's driving us? If we're able to employ our commercial practices because they have to go fast to meet the threat of an adversary or competition to field their products and make profit, maybe we can do that nationally and employ this to meet the threat on the horizon. So I will tell you this, and I want to make sure everybody understands. We have some fabulous weapon systems, and we have fabulous capability. We've done a spectacular job pacing the threat, the Cold War threat, and sort of hit this this dwell period of the only superpower, and we continue to progress. Right, we continue to work on the Joint Strike Fighter. We continue to do all the other things that we do to advance our weapon system. So we're not that bad. Our systems are pretty good. I sort of picked the scab on Aegis just simply to tell you why they had to change. But the Aegis combat system and the weapon system is one of the best, if not the best, in the world as far as doing what it needs to do. Okay, so let's get that. Currently, we're sort of in that boat. We've also made the assertion that software enables our capabilities for our warfighting systems. There's the Joint Strike Fighter does not fly. The F-35 does not fly if the software, any part of the software is not working, right? If the engine software isn't working, it doesn't fly. If the flight controls don't work, which is software controlled, it doesn't work. That aircraft that you fly back and forth, when you get on a Boeing 737 MAX 9, yeah, that's all software, man. That software goes down, you're done. Okay, there's resiliency built in, there's redundancy, there's all these things that is good, but yeah, this software thing is a big deal. So we understand that currently. That's sort of where we're at. If there is a threat, and we believe there's a threat, and China has been explicitly pointed out, nobody is leaving this to question. It's been in the National Defense Strategy. It is in the National Security Strategy. It is everywhere posted that China is the threat. Okay, so that's our target. That's sort of where we're at, and we're worried about their ability to exploit vulnerabilities that they discover or put in our software, and we're worried at the tactical edge, at the pointy end of the spear, whichever service you're in. Our systems are brittle. Most of our warfighting systems were not designed for an advanced persistent threat or a cyber threat, right? They really were not designed for that. We said, hey, we have the gate guard, we have the encryption, we have separated networks, blah blah blah, but they really weren't designed for the threat that's on the horizon today. Okay, and so we have some weaknesses in our system that we need to address, and in particular our new system. So we sort of believe, and we've talked about the why and the what and the who and all this other stuff. We've talked about that. So the pacing threat has changed. All right, we've moved, and hopefully everyone in this class believes the pacing threat has changed. And what is our response? So our response has been, let's change the acquisition process. Let's at least do something and try to go faster, right? So that's the adaptive acquisition framework. There are the six pathways. I think there's 6 or 7 pathways. Everything from the urgent capability needs to the middle tier of acquisition to software pathways, service acquisition, all this other stuff that you can do business systems. So that's sort of our policy change. We've sort of hit the accelerator here and said, hey, we need to change something. So this is all sort of coupled together. If we believe that our software capability, our software is where we get our capabilities on our system, and we want to go fast, then we need to change the way that we develop our software if we need to go fast. And so that's sort of why these are sort of connected. Software acquisition management and the software pathway is definitely interconnected. Also, according to the GAO, and I believe them, the report from, I think, November of last year, they basically said, hey, you're doing pretty good on the pathway. You're doing fairly decent, but what about middle tier, and what about a major capability acquisition? Doesn't seem like you're changing your software methodologies much. How come? So that has been a question, and the DoD has responded saying, yeah, we're going to get to it. Oh, cool. So that's that. And so this is sort of where we're at in the future thinking of things. If you want to go fast and you need to be secure, and you need to be responsive, then DevSecOps is the way to do it. This is policy. I'll show you that. You guys are going to do some review on this, but this is sort of where we're at. We can't do monolithic software and get it to the tactical edge in a timely fashion. It's too big. We don't have the bandwidth. And for many years, the Air Force has said the day without space. The day that we go into conflict with China, don't count on your satellite systems working, right? We've actually, I've noticed over the years, over the last 15 years or so, they said, hey, we're going to lose our satellites. So how else could we communicate? So they're working on that pretty good, and they basically said, what if we do like a bunch of smaller satellites that are less capable? And you'd have a hard time shooting all those suckers down, wouldn't you? So instead of investing in these big billions of dollars satellites, one time put it up there, and like a MUO satellite, it was just a big satellite, big disaster. But instead of putting those up as a target, put up 50 of them and keep sending them up and have that capability. So that's sort of the Starlink principle. That's sort of the SpaceX principle, is you shoot them down, we'll put them up. Okay, fine. A lot of junk up there, but at least that's our response to it. Yeah. So anyway, this ain't a satellite class either, but it's interesting to see our counter moves to these threats. So let's look at the results that we want out of DevSecOps. So this is the beginning. This is the introductory to DevSecOps. So we're going to look at why we want to do DevSecOps. So we've spent some time thinking about the way we've done it in the past, the way that we're trying to move. So let's look at sort of where we're at. Let's understand the motivating factors. Hopefully you understand more today about why we need to change and go to a faster process of developing software, more secure process, and let's sort of start thinking about that. This is going to cost us a lot of money, and it's going to cost us a lot of resources, and it's time consuming. It's going to be painful to make this change. That's sort of the reason I showed you the Lockheed Martin slide of $1.1 billion they're going to spend converting the monolith to microservices. That's what they're on task for, $1.1 billion. So it's interesting as people are now starting to think about it. I got a call a couple weeks from NIWC PAC, and they were asking for some help from NPS on an idea that they have to do to replace the software of the global command and control maritime GeekSim system. Yeah, and I was like, wow. I said, are you looking at breaking the monolith? And they're like, no, we're looking at just redoing the code from scratch. And I was like, wow, okay. That's called greenfield, by the way. If you have a system that is that's sort of working and it's sort of bad. You know, you think the code is bad and it's going to be more effort than it's worth, and you want to just recode it from the beginning. Is just let's just recreate the code and start from scratch. It's called a greenfield event. If you want to break the monolith apart like Aegis is doing, that's called a brownfield event. So anyway, just somebody said greenfield, that's what they're talking about. Okay. The culture. We have a waterfall culture. We have a monolithic culture, and we need to shift our culture and understand what it's going to take from head to tail. What we need to change our contracting strategy. We need to change our financial strategies, the way that we are going to finance this stuff. We need to change the regulations. We need to bring all these interested parties that have a say in fielding this software. We need to bring them to the left. We're going to talk about shift left, and that's what we're really talking about: is bring them in, show them the goodness of this software, and have continuous authority to operate. If I want to push out software, I go through a risk assessment, and if it's a low risk assessment, it gets pushed out without anybody touching it. That it just blows your mind. I got some active duty people in here. Any surface warfare folks, or anybody ever been on a ship?
Yes, sir. I'm a recovering SWO.
Okay, all right. I am a qualified SWO, engineering duty officer. That's what I did in my career. So, but I spent more time on ships. I think I had the most time on ships as a active engineering duty officer than anyone when I retired. My last ship was the Ronald Reagan. But in submariners, yeah, you guys come up for air every now and then, so get some internet or something. Think about the tactical edge. Think about how much time we spend training to get there, and all the workups that we do and everything. Once we start the workup cycle, we don't change anything. No, everything gets locked. This is a process that we have. It's locked down unless there's something breaks. That's it. So you do 6 months, you do however much time you spend training to get to deployment. You go to deployment, you're out there 6 to 9 months, nothing changes out there. You got what you got. And when you come back, you're still in some sort of readiness status, and nothing can change until you get to an availability. That's our culture. Don't change anything. Train with what they got. And so we're going to have some resistance from the operational community until they get on board too. So there's resistances everywhere, right? Culture eats strategy and stuff for lunch. So we got some work to do to change people's minds about what it is we plan on doing and why this is better. So hopefully, my goal in this class, ultimately, the goal of this class is to give you all of the good speaking points and all the negative baggage that comes with it, to be able to defend it, to be able to understand it, and be able to work through it if it's something that you have to deal with. So that's sort of my goal. Yeah, yesterday in yesterday's lecture, the resident class had their lecture on Monday. I had I spent a year in the teaching fellows here at NPS. So it's an opportunity for a year worth of lectures and reading a gob of books on how people learn, how to educate, how to blah blah blah. So yesterday I had the professor who taught the class attend my lecture as a critique. So I graduated yesterday from the teaching fellows. So you can blame her and that program for everything that you're getting in this class, because this is the class I redid based on the teaching fellows concepts and stuff. So hopefully it'll stick what we're talking about. Hopefully the quizzes aren't too painful, that this is sort of reinforcing what it is that we're talking about, and hopefully when you come out of the class, you'll remember something about it. So let's talk about the process of the fundamentals of DevSecOps. So there was a document put out by DoD in March of 2021, 3 years ago, almost to the date, right? 3 years ago. That's how new DevSecOps and getting our processes documented and saying we're going to do this. 3 years. So what is it that they wanted to achieve, the DoD? And they said, hey, we need to improve automation. We need to get out of this manual checking. We need to get out of this manual testing. We need to get out of this because there are tools and capabilities to do automated testing and retesting and continuous testing, all this stuff, integration. We can't do it the El manual way if we want to go fast. So that's the number one thing that they want to get out of this. We want to monitor the software while it's being used. Think about this for a second. This is what the operator, they're going to lose their cookies on this when we tell them this. We're going to give them a system and it's going to go to sea. It's going to be at the pointy edge. And every now and then when it has a problem, when the software has the problem, it's going to call home. And it's going to call into the software factory. And it's going to report the problem that it had automatically. Whenever you have bandwidth, it's going to call home and tell the software factory what's going on. We don't do that in the Navy. 2012, I was meeting with a friend of mine who was the program manager for DSIG's Navy. Distributed Common Ground System Navy. So it goes on the big deck ships and stuff. But anyway, he says, I want us to be able to monitor software while it's out there, but the fleet won't let me do it. So, right, it's 120. I know. Yeah, I worked there for a few years too at 120. I ran C income and F. But anyway. So monitoring is going to be a big deal, but we need it, and the DoD says we need it. So we're going to have to change once again our culture of alone and unafraid to, hey, we're all going to be connected at some way. So we're going to work on the vulnerabilities and everything else, but that's sort of where we're going. And we need to change the way that we think of software and the security of software and how we can build in. You're gonna convince yourself that there is actually ways within software that it can monitor itself and look for cyber events and actually recover from it. You'll convince yourself of that in a couple of weeks. That's what we're talking about. Changing, shifting left. The security people are going to be involved in the development. They're going to be testing while it's being developed. They're going to be verifying that everything has been done correctly during development, not after the stuff has already been done and they have some sort of checklist. No. So, and every phase of the cycle. That's sort of where the DoD is pointing. If we start from a DoD perspective, I know I'm having you read a commercial, guide on DevSecOps, but I'm bringing in the DoD part of it. I'm saving you the pain of having to read through this stuff. These documents suck, from the DoD. Oh God, okay, this is the guide, March 2001. I should be able to read this, and this ought to be the document that everybody understands. It's like, man, it is. Unfortunately, they're focused too much on tools and not on the process. But so this class hopefully will give you both principles. So if I want to deliver value to the warfighter, I can do it using lean principles and collaboration. When we start thinking, I'm intentionally not showing you the infinity circle of DevSecOps. When I talk about this, I'm not, you've seen it, right? It looks like this and it's like continuous. You'll see it, but I'm not showing you that. I don't want you to focus on that. I want you to understand what they're trying to do in DevSecOps, and then we'll look at the infinity circle. Collaboration. When you think about connecting the software coders and the developers with the security people, training them on how to do security better, doing all this stuff in security, and connecting them to the operators, that the operators are getting the software, that we're basically pushing this out. We're connected to them via monitoring telemetry, if you want to use a more technical term. And we're getting their feedback of what they need in almost constant fashion. That is collaboration on steroids, right? We sort of said, well, you know, agile, developing in the development thing, that's sort of collaboration, right? We got a scrum master, we got the product owner, we got the user, we got our dev team, and they're all working together and communicating and stuff. Now it's like, and put everybody else in there. That's sort of where we're focusing this. The difference between DevOps and DevSecOps is there's a word in there. When we say DevSecOps, we're going to do DevOps, but we're going to make sure that we focus on security. Security in the government is very important to us. We brought it up front early when we started thinking about this. I heard the term SecDevOps. And somebody says, no, it's DevSecOps. And they're like, no, we're going to put security up front because it's so important to us. And so anyway, they fought through that for years to finally the DoD settled on DevSecOps. Industry looked at this, the commercial industry, and they're like, you guys are stupid. Why do you need to change the name? We always worry about security in DevOps, right? Who would ever develop software for the financial industry and not worry about security? Okay, so anyway, they've sort of okay, guys, do whatever you want. You know, why don't you call it DevSec test, continuous test ops, or you know, everybody wanted to get their ellipses, but the reason we call it like it is and why it's different than the industry way is we show the security people are engaged in the development of the software. They're engaged. So that was the quiz question on that. Is DevSecOps brings in the security part of it. Okay. So we think we can deliver a better software, better quality software, faster using collaboration and all being connected, being in all that. So let's talk about where this came from. I think this is important. Jacob, you have my slides printed out?
Yes, sir.
I can't even print my slides. I somehow I got disconnected to the printer, but okay, good. So 2009, and you read about this, I think, a little bit. They were doing agile and stuff, and then somebody said, you know, agile's great, but when we connect the operation team to the development team, and in a commercial way, we sort of there's a little bit of difference when we talk DevSecOps and what they talk about in the commercial fashion. When they talk about the ops team, that is the front-facing part of the organization, the commercial organization with the customer. So they're not really talking about the customer. They're talking about their operations team, almost like a software as a service type of thing. But it's okay. We understand the principles. But anyway, they started talking about DevOps and this thing about 2009. 2010, they said, hey, let's all meet together every year in Vegas or some really cool spot, and we can all talk about DevOps and everything that we're doing. In 2013, the book came out on the Phoenix Project. So it's an interesting way to describe DevOps. Has anybody read the Phoenix Project? It's a first person account of them trying to develop software from a project manager's perspective and actually deploying using DevOps. So it's a cool thing to read if you're interested and you like that type of stuff. I don't like reading things in the first person type of context or second person. But anyway, that was written, and then they started reporting on what's going on in DevOps. And so there's an annual report that basically talks about. We'll look at the 2021 one. In 2014, they basically had a enterprise summit, and they said, hey, we need some different type of metrics. If we're going to change from waterfall, if we're going to change from earned value, there has to be other things that we need to measure. And they came up. Google actually was leading this at the time with the DORA metrics. We use the DORA metrics in the DoD. We have a couple additional ones. The Navy also has reconfirmed that we're going to use the DORA metrics. So we'll look at these when we look at metrics, but these are DevOps DevOps research assessments and assessment. So why are metrics important? Anybody know why metrics are important?
You want to see if you're trending towards improvement, either efficiency, more secure, something. So, you gotta measure things on occasion. Over.
Yeah. Yeah, we wanna see if we're improving or if it's getting worse. When we look at the metrics of earned value, what are we measuring on earned value? You guys had the basic lesson.
Cost and schedule.
Cost and schedule. Yeah, right. You're measuring yourself against a baseline that was done during the IBR process, the integrated baseline review at contract award. So if it's a big program, major capability acquisition type of program, if it has a value of a certain amount, you got to do earned value management, and it measures how good your plan was. That's about all it's measuring. It's like earned value management is just measuring how good our plan was from a year ago or 2 years ago. Yeah, how good did you plan it? And they're like, well, no, it has something to do with execution. It's like, well, yeah, it's how good your plan was. If your plan was perfect, you would be spot on earned value. You would never have any deviation. All earned value metrics are only showing you how you're deviating from your plan. So, it's like, oh my God, I have a cost variance and I have a schedule variance and my SPI and my CPI. It's like, okay, what are you going to do about it? Change your plan, called rebaseline. Anyway, that ain't this class, but we'll talk about metrics and earned value management is not a metric we're going to use in software development. Okay, but we'll have that class. You'll agree with me at that point if you don't agree now. Security included. 2017, this is sort of when they said, hey, yeah, okay, maybe DoD has something and we'll include security into this. So it came about 2017 when it was first starting to get truly documented in there. So not that old in the life of our acquisition history. Some of the principles out of the book that are interested in looking at the Phoenix, so that says, hey, the ways of DevOps, focus on flow through the entire system, from the ideation, the figuring out that you could solve a problem or add a capability, through the value creation itself. So focus on this flow. Focus on the process. And this is one of the lean principles, right? This is based on lean too, and make sure that there's nothing in your way to prevent you from delivering capability at the speed at which you want to deliver it. Okay, and that's sort of where we're going. I'll give you a fairly recent example that was in the news. It's sometimes hard to get examples, but when we were doing started to plan the Afghanistan withdrawal, Kessel Run is a software factory run by the Air Force up in Boston, actually in Boston. And it's run by a bunch of Air Force officers and civilians, and they run DevSecOps. They're on task. They have money. They have a customer AMC, Air Mobility Command, and they came to Air Mobility Command and said, "Hey, there's something we're missing. There's some software that we need in order to be successful in this Afghanistan evacuation, the withdrawal. Can you give it? We need it within 48 hours." Is what they told Kessel Run. We need this new capability in 48 hours, sorry. And hey, they're fully staffed, they're fully manned, they have contractors on task doing something else, and they said, sure. They gave that capability to them in 24 hours, is the report. And it was substantial. It was a capability that they needed, some sort of planning capability. But anyway, that's what we're talking about. The user basically turning to us, and we can basically have this value flow from beginning to end, and we know how long it's going to take for us to deliver something and have the security. And so that's one of the ways of the Phoenix, the 2013 book. Creating feedback loops. We all know that this is important. You just don't keep doing it and never ask for any advice or any opinion, right? You gotta get the feedback loops to get better and make sure your quality is where it needs to be. So that's the second principle. The third one is driving experimentation and learning. We have a culture of not taking risk. A DoD culture is a risk-averse culture, right? We don't like to fail. In the military, we don't like to fail. You know, we try to understand the risk, and if the risk is too high, we just don't do it. If we can have that luxury, do it. Try something, build a prototype of it, experiment with it, learn from it, and if it fails, that's okay. That is going to be a challenge for us, right? Who actually develops the software for the DoD? Anybody know?
Private industry, software developers.
Contractors. Private industry, the people that want to do business with us, develop the software for us under our guidance, and we give them money and we oversight. That's what DoD acquisition is, right? We don't, for the most part, we don't build anything in the government. We are we're the oversight, we're the management of it. Okay, if that's a big surprise to you, I hate to bust your bubble, but that's now it's like, well, we got these warfighting labs, and we got like Nywick Pack and Nywick Lant. Don't they build stuff? Yeah, a little bit of it. But for the primary capabilities we're talking about, it's built by defense contractors and under our supervision as the acquisition people. So we got to let contractors fail. We've got to let them try something and understand that we're not always going to get it right. And we need to fail fast, and we need to learn from it. All right, Elaine.
Hi, sir. Yeah, so I know that is the typical construct, but you know, things are moving pretty fast as well. And from the last deployment that my strike group was under, we're trying to break that construct with IWS, NIWC, NAVWAR, as well as some of the other elements. And yeah, I got it. The operators too, they're operating. That probably won't change, but being able to take on more risk and given the breathing space to fail fast and fail often, with little risk, and it being about software, I think is really what a lot of folks are the appetites for.
Yeah, and it's called psychological safety. We got to build in the space in the DoD for us to take an experiment and understand that we're not going to get it right all the time, and learn something from it, right? Just don't fail for failing purposes. Fail and learn something. That's really good. But yeah, that's good. I'm glad you mentioned that. But that culture is, and we got to work through this to understand, our incentive structure on contractors is based on cost performance. right? Cost plus incentive fees are based on cost incentives. Okay, we want performance incentives, so we got to change. That's why I said we got to change our contracting structure too. Maybe Randy, go ahead.
Hey, I apologize. I've been in and out of the meeting, and maybe has the term DARPA come up at all? And the specific question is, DARPA been on the cutting edge of general DoD software development over the years? Over?
DARPA, I'm gonna be careful what I say here. I'm a recorded lecture here, but DARPA has some smart people that work in DARPA, but they're primarily a contracting organization, right?
Okay.
They
Yeah.
bring in contractors to do this exploration, this TRL level 1, 2, and 3 type of stuff.
Okay.
So that DARPA's was good when they were pushing the internet and all this other type of stuff way back then, but they ain't really done nothing spectacular in the software world since.
Okay.
Industry. So I would say industry has led this whole process. It really, if you look at you've been around a little while. We had this tech bubble burst in about year 2000, right? It was like the Internet of Things, and we're going to build, and all these small companies basically came up, and then it just for other reasons besides, but that's where all this agile stuff came from, and this is sort of how competition and everything came about. It all came from industry, so that's why we're trying to leverage some of the stuff. But yeah, DARPA, not it.
Got it.
The unicorn is a follow-on to the Phoenix, and basically as they go through here, these are the five ideas. We'll just click through here, but as you start looking at some of this, joy, focus, flow, and joy. The people that are doing the work, the coders, the testers, the security people, everybody is happy to be doing the work. I'm trying to over dramatize this, but software coders don't really live a good life if they're not doing DevSecOps or Agile, okay? Because they're like, okay, the plan's coming, and the design's coming. It's usually going to be late. They don't change the release date of when they need the capability released. So who gets jammed is the coders and the developers. They get jammed into now we got to work, these 60, 70-hour weeks, work all night, work on this, and they get compressed, and they ain't happy people, right? A lot of them have other problems that come out of it. My son worked at Microsoft. The reason I'm mentioning this is he was at Microsoft, came right out of college, went to Microsoft, and he's all, on the leading edge of a software development, a mobile device that they were doorbell. They're at the leading edge of this, and he describes this state of happening. Our release date's going to be in April of this year, and the window keeps on pushing on us to where then they had to do all this crazy stuff. So we gotta fix that. That's the reason. When we look at Agile and we look at DevSecOps, it's a much different methodology, and it's really to protect the people that are doing the work. We're like, well, why do we care? That's contractor problem, right? Well, we got to care, right? We want good quality software. We want the contractor to come back and do work for us. So we got to change our processes and the way that we deal with them also. So improvement of their daily work is important. Psychological safety. What the heck is that? What is psychological safety?
Is that like not being afraid to fail?
I've been watching these TikTok videos, I hate to admit it, of skateboarders trying to do these stunts and landing on their face. And I think that's just, I get it. And my wife is like, why are you watching that? I was like, they are not afraid to fail. I mean, they like bust their face wide open and out and like, no, that's not it. Go ahead, Randy.
I really was just going to wing it and just say that they feel safe in their mission, no matter, you know, what they're working on. They just feel safe where they're at, that they're not going to get ostracized. They're not going to get forced to do something immoral or all kinds of other things. I would put that in there. Over.
Oh, that makes sense. It's like the blame thing.
Yeah, it's the blame thing. It's the when we went through Agile, remember there was a retrospective, and in a retrospective, they weren't pointing, you know, they didn't say, you know, Jeff Dunlap, it was your fault that, you know, this particular code didn't work. It's like, no, they don't blame. They basically try to learn from it. And so that's a form of psychological safety. Knowing that it's okay to fail and learn from it is a psychological safety thing. Not being afraid to tell the emperor he has no clothes. Yeah, that usually that can go bad really fast if the emperor doesn't want to hear it. But yeah, sure, why not? Josh?
I was going to also add, I think the book touched on fear without reprisal or like a negative connotation to it.
Yeah, exactly. So when we deal with our contractor doing this work for us, we're trying to incentivize them to do quality work and good stuff. But when it fails and something doesn't go right, we need to sort of hold our blame mentality to and actually shift the way that we think about this. And it's like, okay, it's fine, it's all right to fail, sort of like what was mentioned, but let's have the safety in there, where we're not ostracizing someone or blaming somebody, and let's learn from it. Okay. Custom focus, of course. Now, the calms one, they went through that one also. There's my S. A culture. You have to develop a culture. Most people who fail doing Agile or DevSecOps did not know they needed to change their culture. That's the number one reason, is the culture in that organization was not ready, or they didn't have the processes in place when they started it, and that's the reason they failed. That's sort of the going thought. So we've been talking culture, we've been talking culture in this class for 3 weeks. I'm talking this week about culture. What do we need to change in order to be successful? What's our relationship need to be with the contractor to be successful? What's our relationship with the customer to be all this other stuff? Automation, of course, you're going to get this in spades next week when we go into the technology of this. Lean, of course, we don't teach lean, but this is the principle of making sure that it's as efficient as it possibly can be. There's no roadblocks that don't make any sense. Measurement, we've talked a little bit about the DORA metrics. We have a whole class dedicated to measurements and metrics and sharing the learning. What did we learn? So in the DoD, we're not really good at sharing cross services. We know the Air Force is sort of a leader in the software thought process. They basically established a bunch of stuff on their own. They said, if you guys can't figure it out, we'll do it. And so Platform One was an Air Force idea of having all the tools in the cloud, and all you had to do if you wanted to code software was to use this and pay some sort of subscription fee, and it was good to go. We'll talk about Platform One, it's hard, and all the services said, well, we're going to do it, but we're going to do it this way, and we're going to do it that way. And finally, the DoD stood up, and I showed you that document in 2021 saying, okay, everybody's going to do it like this. And we need a standardization. We can't spend money differently in the Air Force than we're doing in the Navy. Why we're building too much redundancy, and we're wasting too much money by rebuilding the software factory every time. So anyway, we'll talk about that in the future. So that's some of the ideas that came out of these books as they were trying to describe what DevSecOps was, what is the principles of it. And you know, we sort of, we should understand waterfall and our milestone A, milestone B, milestone C. It's all about planning and doing all this work, but the customers are sort of out of it, right? It's where we are in what we think that we need to go to be where the customer ultimately what they want. And in waterfall, what we actually discover is sometimes the customer, what they want and what they want it to be changes, and we don't change. Waterfall just can't do it, right? You plan, you got it. That's what you're getting 6 years from now. In Agile and DevSecOps, it's sort of it's iterative. It can flex. It actually is built in to actually respond to what the customer actually wants. So we got to stop thinking that it's all about us in acquisition and DoD, and it's all about the warfighter and the customer and the ultimate user. So that's sort of this culture shift too. Is like, what do you mean it's not about us? It's like, yeah, it's never been about you. It's always been about them. So why wouldn't you pivot to be like that? And so in traditional waterfall-based software development, that's this methodology, the teams are separated. Okay, I think that's really the point here. You got the coders and the developers are here. You got the security people are over there, and then you have your operations and the users are over there. They're disconnected and they're not communicating, and this just really drives a lot of pain into the whole process for everybody. There's a lot of handoffs between the software or the capability that we're developing, right? Think about it. We have our contractor, we do DT, developer testing, right? We get our government experts go in and they're looking at, you know, some early, are they meeting the requirements of the design, doing what it's supposed to do? And then we hand it off to the operational folks, OT, right? The operational testers. And we say, good luck with that, you know, and tell us if it's suitable and effective. This is built into it. Here's a bonus quiz question for you, and then we'll take a break. Has the F-35 finished its operational testing? Will it ever finish its operational testing?
No, it has not. They're still in LRIP, and they will be in LRIP until the end of time.
Yeah, they've done site map. It's too big to fail. They are continuing, and they're like, well, why would we ever be done testing? If we keep adding new capabilities to it, that means we must continue to test. So yeah, they're in a death spiral. But anyway, let's take the break. So as we talked about the waterfall methodology, you can see that this is a handoff type of thing. Everything from the system engineers getting all their system requirements and passing it on to the software folks, and the software folks looking at it and figuring out how they're going to do this and blah, 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 blah. You can tell it's definitely a manual process, a very segmented process. So that's we don't want to do that if it makes sense, if you know everything that you need to know, but for the most part, that's not what we're going to be talking. And as we start thinking about this leaning out the process, and, you know, the development teams basically handing off the product to the operations team, who won't even start looking at it until they get a finished product and it's ready for production. And so after everything's complete, they look at the product, and then they do all this testing on it, right? This extensive look at it. Maintainability is all the stuff that the operational folks look at. And then they discover all these defects and they send it back to the developers, say, hey, go fix that. Well, the developers aren't just like on vacation, right? They're probably going to work on something else. So you're just like, wait a minute, you know, come back. You gotta address this. So you can start seeing that this is not a lean process. It's definitely not a collaborative process. The waterfall methodology as we go through this. This culture of waterfall creates a blame-based culture. We're blaming the developers who are working on the next thing, that this stuff isn't working right, and it constantly causes refocus of the teams to go fix this. and it just causes further delay. So you can hopefully you're a believer that this waterfall methodology, the culture that it basically creates is a blame-based culture. And if we need to change and come into this psychological safety and all this other thing that we need to create, we got to change our culture before we start trying to do DevSecOps. Okay, and that's like I mentioned, it's going to be a challenge. So what is it? If we take agile principles of agile or iterative, and we extend them beyond code check-in and to actually connect the operators and the cybersecurity people together. That's sort of what it looks like. I had you write about this picture. What does this mean? What are these circles representing? I said there's something here. You can sort of see where all these circles are sort of connecting inside here. Somebody said, "Oh, this is a Venn diagram." I hated Venn diagrams. What was that? 5th grade math or something. I was like, what the hell is this all about? Well, this is a conceptual thing. It's not like, and it's the same way when you look at the 3 rings of big A acquisition, right? The JSIDS process, the budgeting process, and defense acquisition system. And we say, hey, if one of these get out of alignment, then if you don't get your budget right, you don't get the requirements right, then everything just comes off the rails. You can sort of look at it like that. I think this is good to talk about and think about. You got your development organization, you got your operations organization, cybersecurity people, your security people are involved and engaged in this. And insurance. I mean, what the heck is quality assurance, and why is that there? Anybody want to take a guess at why? Is there a quality assurance organization, or is it something else they're trying to convey?
Wouldn't quality assurance be like your testing?
Yeah, absolutely. It's building in quality assurance that we want to deliver a defect-free product. It's the built-in automated testing. It's the continuous integration stuff. It's everybody's job to build a quality product, and quality includes cybersecurity, right? Defect-free, secure type of software, all this stuff. So yeah, it's. I was surprised nobody really mentioned that in their homework. Randy, go ahead.
Yeah, hi. I just wanted to point out in my world, construction, there is a difference between assurance and control. So they're not the same thing. Quality control is typically on the contractor side to ensure that quality changes are made in the production so that quality is built in. But then that assurance is outside. It's somebody that says, is it in or is it not, or how far is it in within quality standards? And so I would guess that in this Venn diagram, there are quality control people in the other 3 circles, so to speak, that are folks that are focused on the control part, and then assurance is outside of that. Over.
Yeah, I think there's similarities for sure. I think what they're trying to express in here, the process itself, the way we set up the software factory, the process itself actually builds in quality assurance. It's built in, not tested out. Matthew?
Yeah, I was gonna say the biggest takeaway when complete focus. So having the user engaged early in the process is critical for, I think, the process. Because if it doesn't work for the future, if there's a change in requirements, which is like the ethos of everything agile and lean, which is kind of like the QA to me, the ultimate QA, not just for quality assurance, but the fleet actually agrees where we're heading. Over.
No, I'd agree. I'd agree with what you said. What I caught of it, you are a little bit broken, but that's okay. I got the gist of it. Yeah. When we looked at the number of defects in the Aegis and ship self-defense combat system, yeah, not a lot of quality. You wouldn't say that's a quality product if it has that much so many technical debt deficiencies built in. Yeah. Yeah, it's good to think about things that they're connected. This connection between it, and that's what we're really talking about. We're all communicating. We're connected. We're working together. We have our process leaned out. We have a flow going through to where everybody is starting to get capability that they want. So that's sort of how it is. We've had some challenges and with our security teams, our security experts, our cybersecurity experts. They've sort of been slow to want to come in and participate, right? They're sort of used to like, let me check the box. I'm sorry, Matthew, you still had your hand up? So as like any organization, it's hard for them to change and get into a different type of culture mindset. Their mindset has been in reducing the risk of having a cyber event or getting an exploit, and so that's sort of what they're sort of used to doing, right? Remember, it was DITSCAP, it was DIACAP, and now it's RMF, Risk Management Framework, for cybersecurity purposes. I think we have a lecture to talk about that. Is it next week, or is it this week? Yeah, one of those weeks. So anyway, we'll talk about the security teams, and we'll talk about this silo of secrecy. They would not communicate with the developers, the coders, say, hey, this is a common thing. You need to fix this. So if you can get them in early and they're communicating and working with the developer teams, then this is the change of culture that we have to sort of get moving forward. So anyway, just a little bit of note of resistance. The state of DevOps report, I've mentioned that they do this every year. This is industry, commercial industry. They basically said there's a lot of value in working software in these high performance teams using DevOps. And they start talking about what are we measuring and how can we show that they're actually performing better. They start talking about deployment of code. How fast can they deploy code to the users and frequently? They start using the word velocity, and we're going to use that word also. That's one of the metrics that we in the DORA metrics. Velocity is how fast you can get through the process to deploy the software, right? It's a measure of from the time that you start to the time that you get it out into their hands. That's velocity. You could say, well, that isn't that speed. It's like, well, velocity has a direction. So that's the way to call it, the direction to get it out there to the user. Quality is sort of built into it with high performing DevOps teams. They have less failure rates of the software as they go through this, and they're able to restore the service if it's software as a service is their product. They're able to restore the service a lot faster, and you can think of this as like a build of the software. So that's sort of where they're going. This image came out of the DevSecOps Enterprise Strategy Guide from 2021. So they said, hey, this is this document. We got a bunch of other documents that they basically said this is how we're going to do things. We're going to talk about Kubernetes in the future as we go through the design of the factory itself and the products, the software products. But I want to show you this picture here because it's important because we're the leadership, DoD, CIO, and the DoD leadership is saying this is how we're going to do it, and I think that's really important to sort of grasp. And in week 5, I've already set the week 5 assignment. Or we're going to spend Tuesday in week 5 having you guys present some of the concepts of DevSecOps. So I've already set the teams. You can go look at the assignment. So it's teams of 3 or 4 people. Basically, you got an assignment to do a 15-minute presentation to the class, and with the follow-up questions or comments from me or the class, and we'll basically flow it through there. So I left it pretty vague. And I've teamed you guys up. You probably don't know each other. You don't probably not even in the same workspace for sure, or time zone. Some people, but go figure that out. You got till week 5 to do that. Anyway, any questions about anything that we talked about in this slide deck? So DevSecOps, the security part of this is the cybersecurity thing. How do we build in multiple layers of security and still let us use the system the way we need to use the system? That has always been the challenge. We need to move away from cybersecurity at the perimeter to moving to a culture and an understanding of zero trust. And why this is important from a design perspective and why we embrace this in DevSecOps as the underlying principle. So if you think about the good old days of software distribution, it sort of matched what the media was that we were distributing software on. Back in the 80s, in the 1980s, you'd get a bunch of floppy disks. We called them floppy disks back then, even though they stopped being floppy at some point. And then we moved to DVDs, right? You get a DVD in the mail. Here's your new software update. That was sort of our it was slow, right? It was slow. They had to put it in the mail, or you went and bought it at the store. You had to unwrap it. You had to load it up. You had to do all this other stuff. In 1988, I remember this. And it wasn't Windows in 1988. Windows didn't come out till after that a little bit. Well, anyway, I remember uploading my operating system. I had uploaded a new version of operating system, which was not Windows, but I remember it was 24 disks and they were in order. You had to do number 1, number 2, number 3, number 4, blah, 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 blah. It took like a half hour, an hour and a half to just load the disk in and have them read it and da da da. So you can start seeing, waterfall. Okay, be slow. Doesn't make any much of a difference because this is just sort of how we distribute stuff. When I was working Tomahawk weapons control system in Pax River, the software was being developed down in Dahlgren, Virginia, with Lockheed Martin basically as the contractor. And anyway, the software development, every time they would load it on big tapes. It was a big tape drive that they had, and they would back up the software, and we'd have 2 copies of it because in case the building burnt down, we had to have a spare copy somewhere that we could recover and keep where we're going. So this is where we came from. Okay, people. Some people are old enough, like Randy and me. We understand. We know this, and the rest of you youngins, just believe it. We didn't have internet back then. That was sort of where we're going today. Yeah, AOL, yeah. Prodigy. That was another thing that before the internet. So these legacy software development, it wasn't wrong. It just sort of matched it. If you start looking at the advent of the internet, when did Al Gore discover the internet or build the internet? Sort of a running joke, right? He sort of when was it?
86 or something.
Yeah, that was at the labs and the universities. When did it really become the internet?
Because I'm the other old guy on, I can recall maybe as I was starting college in the late 80s, early 90s, we could this idea of AOL and
Was AOL
getting online was the new thing.
Yeah, I mean, we had services, right? I mean, I know we're going down a dirt road here, but it's important to sort of think about. And when I was on my first ship on a frigate in 87, there was no internet. Okay, we had one computer in the operations office, so they could basically type their messages and then burn it then put it onto a tape with holes in it to where they could read it, send out the message over the radio. Okay, that was sort of where we were. But yeah, we started. The bulletin board system was sort of out there, right? You could download software, you could talk to people, sort of chat. That sort of was the beginning, but it was a point-to-point. AOL is a point-to-point service. you had to go log into AOL and you were on their services. So it was connected. I wouldn't call it the Internet of Things, but it was the first, something other, than, and it was all, the modems. We had modems in our computers back then. They have to sync and make all this funny noises. I know people are like, shit. When I was here at NPS, getting my master's degree, I graduated in December of '92, and when I got to the shipyard in Charleston, my first assignment as an engineering duty officer, they said, "Here's your computer and it's connected to the internet." And I'm like, "What is that?" And they're like, "Yeah, you can go search for stuff." Okay, that's sort of where we're at. So I'm telling you that and it was like I think Mozilla was the browser or something. It's like, yeah,
Yeah, Mozilla. Mhm.
yeah, if you wanna search for something, all you got to do is type it in and it'll tell you. No, that was okay. But anyway, that's where we're talking about the internet is in that time frame. So probably I know for sure. I know the DL students, you guys are a little bit older than my resident students here, but I start getting the eyeball roll of like I was born in the year 2000, so don't even talk about 1990. Yeah, okay, cool. That was pretty close with when it was starting to come up. So internet sort of changed things in the commercial market, right? It became a marketplace that we could develop apps, we could build apps, we could build stuff, and it was really the start of different thinking about software differently, and the delivery method became different. So that's sort of where it all sort of happened. Software as a service applications were hosted by the provider. So that was AOL, that was all these other types of things. But that was sort of the rise of, you can use the software, you can go to the cloud and use the software, right? Where's the compute? Or is this just a display, or is it going, it's just like Zoom, right? We're using an application that's connecting to some server somewhere that's storing all the recording and making all this stuff work. It's not my computer that's making it work, it's somewhere else. And these technologies have emerged to allow us to do DevSecOps, right? The emergence of all of this has been the predecessor of, and the commercial marketplace has embraced it, and the DoD has ignored it, okay? For whatever reason, culture, why not? Plain culture. Our thinking of security has changed dramatically too, right? My computer on the frigate was not connected to anything. Nobody could exploit it. They couldn't do any unless I was to put into a floppy disk into it and it had some sort of malicious code on it. It just didn't happen, right? We had a security at the perimeter type of stuff, so this massive shift of thinking that we're secure because we're behind some sort of encryption, sometimes some sort of gate guard. This is a big deal. This is that type of defense is important, but it's not complete in today's environment. We have to build our systems to be more resistant to the being connected to other things and an advanced persistent threat like China and Russia wanting to exploit and expose all the problems that are in our system. So that's sort of where we're going with the cybersecurity type of discussion. This is not a cybersecurity class, but it's important to understand how we're building this into our software. So we got to move away from thinking that we're secure because we have perimeter security to build it into the software. And you may be asking, well, how do we do that, Professor? I'm going to tell you. You're going to learn it. And in week 6, you'll come away from week 6 and week 7 saying, oh, that's what you meant by build it in. Yeah. So I won't spoil it for you. I'll let you wait till we get to that point to tell you how we're actually going to do it. But we can do it. It is a big deal. So y'all know that with email, we're trained. Don't click on a link from some source you don't know. And personally, don't click on any link. And we get this training annually, right? We get the cybersecurity training. You all know this, the phishing attacks, all this other stuff that's in there. And where we get this all there, chapter 6. So this is really exposed a pretty open gap, right? We get these, and we understand this from a national security perspective also, right? What was last year? The pipeline had a ransomware attack, and the gas stopped flowing up the East Coast. People lost their freaking mind. Oh my God, I don't have gas. I got to go buy gas so I can hoard it, right? That's just the culture. You know, when we had this pandemic thing happen a couple years ago, and I'm here at NPS, and they say go home, and so I was like, man, I better get home. I hope they don't have the highways blocked and shit. Anyway, I got there, and I went to Costco. I just needed dog food or something, and the people are buying water. I mean, cases and cases of water. I'm like, what did I miss here? Is the COVID virus spread by drinking water out of your tap? And this was California. So their response was, when they seen emergencies like hurricanes and things like that, people went to go buy water. So in California, we don't have those events. All right, we have an earthquake and it happens, and we don't, you're either prepared or not. But here we had to prepare for something. They said, well, then we must buy water, and we must buy toilet paper, because that's what people do when there's a hurricane coming. I mean, it was ludicrous. But anyway, we have to know the threats that are on the horizon. We get the training, and we're educated on this. My aunt, I think this is probably her 4th time she's got my Facebook account's been hacked. I said, really? They're just targeting you, aren't they? You never clicked on something. You never gave any information. Somebody sent you to a page and asked for your Facebook ID and your password. You never did that, right? That's all being done to you by some malicious activity. So, that's it's so we think that having our industry, our industrial base, making them more secure, sharing knowledge with them on how to prevent stuff like this is in our national interest. So that's sort of where we're headed on this. So the attack surface, we start using these words of attack surface, and it's basically where can they attack you? When you had a perimeter defense, they could only attack you one way, right? They had to come into your computer. You had to have it on the floppy disk. You had to do it that way. When it connected to the internet, it could come anywhere, and that's sort of what we consider when we think about cybersecurity. The fight's on, where we have to defend the network. We have to defend our systems against cyber attacks. We have to build our system to be resilient. A big deal, and we're going to talk about that. So it's changed from individuals to nation states. If you don't think China has an entire building filled with, I think the number was 10,000 Chinese in a building, and their main goal is to find exploits and or build in attacks. And they're right across from a university there that they have in China, and so basically that's they're getting university people that are educated in this, and they come over and they start working for the government to figure out how to break our systems and how to do this stuff. My biggest fear of this, like in Taiwan, when they decide they're going to take Taiwan and we show up with our ships, they turn off our combat systems. They turn off something on the ship and we have to go home, right? That would be like the devastating cyber attack. They're not going to show their hand. They're not going to attack us until they're ready. And it's already in our systems. That's sort of what we're thinking, but it's sort of scary. This connection of the internet, everything being connected, is the attack surface, the attack vectors. As we start thinking about this, now the reason we're talking about this is we're going to have to build this into our software, right? We have to understand what our software is going to be exposed to and build it as secure as it possibly can be and still function like it should. Attack vectors is the pathways to the attack. just some information on corporations losing information. TJ Maxx lost 45 million credit cards and debit numbers. You know, they want them, they can use them, right? And Target lost 40 million and 14. In 2017, there was Equifax breach. What else? I'm gonna talk about the Navy lost a lot of information, personal information at OMB. We'll talk about that. So the attacks are getting sophisticated and multiple attack vectors. So not only are they going to attack you one direction, they're going to attack you over here, and then they're also going to attack you over there. Go ahead, Randy.
Yeah, and I wanted to ask you a question about those kinds of commercial hacks where they, you know, some commercial enterprise is hacked and a bunch of people's numbers are stolen. And it leads to my question is, why do they keep the numbers? What is it that they need the number for? Because anytime you want to purchase something, you give them the number back. Why do they bother the risk of holding all this data in a separate system?
It's convenience. I was so my Airbnb. I got an alert from USAA. No, I got an alert from Airbnb saying you successfully booked your stay in Sydney, Australia, at 5:15 in the morning. I'm like, what? I'm not going. Did I get drunk last night and I booked something in Australia? I'm like, what the shit is this? So I try to get into my Airbnb account and it won't let me in. I was like, what? So Airbnb keeps your credit card information for the convenience of you want to rebook it. Yeah. So I call Airbnb. Of course, I get India, and they're like, well, it looks like you created a new account. I was like, yeah, I had to create a new account because my old account got deleted. You have a feature in your software that if you want to delete the account, all you got to do is press a button and it deletes the account. So this person got into my account and booked a non-refundable vacation in Sydney. I was like, well, that sort of seems suspicious, right? Somebody set up some sort of account to where they're getting the money. There's no place in Sydney. This is just a fake thing to get money, right? And the way they cover their tracks is they deleted my account. But when they deleted my account, it canceled all my future reservations too. So it gave me all my money back, my deposits for deer hunting and a wedding I'm going to. And they're like, yeah, we're going to escalate this to, you know, and I said, well, what am I going to hear about this? And they're like, we're going to escalate it to Ohio, and they're going to be looking at it. I was like, all right. So yeah, I called a credit card company, of course, and they're like, okay, we'll stop it and we'll do an investigation. So $3,000, and it destroyed my account. Right, I had all these good reviews by all these fabulous people, and everything just went with. And I was like, well, could it have been me that I reused my password in places and somehow my password has been exposed and this was an easy way for them to get money? I don't know. Probably was.
It just seems like that would be something that companies would be thinking, and the DoD too. Like, if you hold data, you have to spend money and time securing it. If you give it to a secure microservice, you just need access to it. I guess
you know, it's convenience. It's like I go camping a lot in California, and the state of California has a web service that you can book on. They don't keep your credit card information. They know where you live, that information, but every time I got to put in my credit card information. I was like, what a bother. Why don't they remember this, blah, blah, blah. So anyway, I mean, yes, there's the customer convenience of it versus the security of it. So most, I know most government organizations don't keep the credit card. You have to put it in every time. I know.
Copy. Okay.
Yeah. All right. So speaking of sophisticated lateral movement, we're seeing that a breach system can affect adjacent systems. This is the SolarWinds thing that we're going to talk about that happened a few years ago. Ransomware attacks was based on this rise of cryptocurrency. So, you know, you can't really track cryptocurrency. So when they ask for money, they don't ask for dollars. They're asking for Bitcoin or whatever. So this was the Office of Personnel Management, there was a thing that happened in 2015. They lost 21.5 million Social Security numbers, and that was stolen from background investigation thing. So this was a big deal back then. This was government workers. This was retired federal employees. It was everybody, the family members. So it was a big deal. What do they do with Social Security numbers? Well, they can file your tax return if they know your age, they know your information, and they know your Social Security number. They can file a fake federal return and ask for a check that they can cash. I don't know what you do with Social Security numbers. It's another vector that you have to sort of defend against. Supply chain attacks is a rising concern, and they understand that we're going to build systems that are cyber secure, but if they can attack the supply chain and give you a counterfeit part, or they can give you something that has malicious code already embedded in it that you can't detect, this is the concern that we have. Maybe a little bit of the CHIPS Act that was enacted a while back, a couple years ago, maybe a couple years ago. We need to make sure that things are made in America, that we have control of the supply chain. We got to stop buying things from our adversaries, potential adversaries. Maybe that's sort of where we're going. So as we start looking at and in case you don't know, every weapon system, every system that the U.S. is developing, we have to know where all the parts come from, right? And if it's a foreign part, we have to determine it's a trusted part from maybe a partner. But this is sort of what we do. We have driven this down all the way. We got to verify every computer component, every chip, every piece that goes in there to make sure that at least we know where it's coming from, and hopefully we have trust that there's no embedded vulnerability in this stuff. So that's sort of where we're going. Open source products. This starts arising when we start talking about the tools of the software factory, right? We're going to use all these commercial products. It's like, okay, they just came out with a new version of this product. Can I accept it or not? Or do we need to look at it and make sure that it doesn't have any vulnerabilities in the open source world? So this is another layer of maybe it's going to slow us down, because we have to ensure that the products that we're using to develop our software itself doesn't have a problem. And so these are products and services that we're going to use in our software development environment and DevSecOps, and we have to be aware of this and the risk of using some of this stuff. This is the solar. Anybody heard of SolarWinds before? I did. I met them at AFCEA West 2 years ago, and they were handing out coasters. And I said, SolarWinds, it sounds familiar. Anybody know what happened with SolarWinds?
Yes, sir. There was a supply chain exploit on some of the software code. And if you ever want to listen to the after action reports and some of the working groups that CISA did in going through and investigating that's all openly available. But based on some of the databases that they were in charge of for cybersecurity, as well as some of the other products that they provide software based, pretty much run them out of business based on that major exploit. And there's still software, as I understand, that has the potential to still be exploited. But we'll see.
So basically, they trace it, and it's, thank you. It's a good report as they do the decomposition of this. They found that these hackers did a test run in October 2019, and they were able to put malicious code in the files. Blah, blah, blah. So they did all this stuff, and they proved that they could actually get it done. So they know that the adversaries, the hackers, were in the system at least all the way back to 2019, not earlier. So what SolarWinds provided, they're a software as a service. It is the software that folks use to to monitor their networks, to do network balancing, whatever else, blah, 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 doesn't really matter. But it was a software as a service. And so they basically, all these customers are using it, to use this piece of software that is being provided. They pay for it, like an annual contract or whatever it is, that the service. But they're all using it and they trust it and everything. And FireEye is a company that does cybersecurity, and they noticed something was going on their system. And they were like, what just happened? Something, they basically traced down, they had a vulnerability, an attack that was basically coming through SolarWinds. So basically, they told they, nothing like a cybersecurity company to get hacked, and whatever reason why these people were doing this. But anyway, they discovered that it was a cyber intrusion that basically was coming through the application and infected their servers, and an advanced persistent threat, Russia, China, who knows, basically were able to infiltrate the systems that were connected via supply chain attack through SolarWinds. So they inserted a backdoor into the product, infected. It was pushed to 180,000 customers that were using the Orion platform, including the U.S. Treasury, Commerce Department, Department of Energy, the National Nuclear Security Administration. Pretty big deal, right? Here you're trying to defend yourself at the perimeter, and you're trusting a commercial software provider, and it was the attack vector. That's how they got in, to do whatever they were going to do, right? It's like shut down the Treasury, shut down all the services that or do something. We're still not 100% sure exactly what it is they did and why they did it, but yeah. The DoD isn't listed in there. I don't know if they were involved in it, but this is what was publicly reported. So this evolution in cybersecurity and our response. This is sort of where, as we start thinking about defense in depth, right? It's a layered approach, and as we start thinking about cybersecurity, and it includes every layer of operations and the infrastructure. So we got to have layered defense. We have to have active defense. So when we detect something, we're able to respond and recover and be resilient in the response. So we need to be able to slow down the progression of the attack by our design using different layers and mechanisms, okay? So a layered approach to security, from the data that we want to protect, the host system, the application, the network that it's connecting to the perimeter. This is as we start thinking about how we're going to understand all of the risk associated with a cyber event, and how do we defend it? How do we include, how do we operate the system and the governance that sort of connects to it? So this leads us into risk management framework. This is the DoD process for considering cyber and working through the process of defending the software and the systems that we are developing. Okay. Anybody ever heard of the risk management framework? It's cyber risk, not like risk.
Definitely. In my business in utilities, in facilities, utility systems and the control, supervisory control and data acquisition, for example, remote controlling valves and pumps and components like that, measurement devices is connected. And so we use the RMF to make sure that those connections are secure. Yeah.
So the system we had before RMF was DIACAP. And it was DoD Information Assurance Certification Accreditation Process, DIACAP. We stopped calling it information assurance and we started talking cyber, right? Let's call it what it is. And that gives us a much broader view of it. It's applicable to all DoD IT systems that we develop or use and store, display, or transmit DoD information, right? And we'll talk a little bit about the approach of RMF. I'm not going to teach RMF because this is, like I said, is not a cyber class, but this is important to know that this is the process that integrates the security and privacy and cyber supply chain risk stuff into a process. So it is a very deliberate way of thinking about risk and the ability to control and make effective decisions on the way that we're going to protect our stuff. And so this is managing organizational risk from a cyber perspective. Here's the instruction for it. Look how new it is. We're right on the ball when we make a decision to consider cyber and to do a different way of protecting our information. Right, we went from DIACAP from a process of checking the box to, well, let's consider all the risk and see what we can do to protect it. So it is truly a risk-based type of decision, how much risk we're willing to take in our systems when we allow it to connect and allow it to do this, and how do we protect the systems better. So this is the document. It's connected to the Defense Acquisition System, our DoD, our phases and stuff, and it basically is our process to shift left. It really is, let's get it in early, let's consider it, right? Remember when you looked at the adaptive acquisition framework, there was this big red bar right at the front of it, if you can't recollect, and it said, you've got to consider cybersecurity first before you start your process of building something. How are you going to defend it? How are you going to consider all the risk of doing this stuff? So it's, we do this as early as possible in the acquisition processes, and with the intent of increasing the security of our systems that we're developing and decreasing cost. Get it in early and go through this process, and it's used in our acquisition process, and we're trying to make deliberate decisions based on the threat information we get from our intelligence agency. So this is how our intelligence agencies impact acquisition, right? They're basically advising us, if you're going to build this type of system, here are the threats. This is what we know, and then you need to build a system that is able to defend against that or operate in that environment. And so we consider everything within the system as we're developing it, and we basically design it to be handle the risk environment which is going to live in. So here is the framework of the model. I think it's worth looking at as we start thinking about how, this is what we think about when we're developing this stuff. This is when we're designing the software systems. These are the things that we have to consider. And so it goes through a very deliberate build out here of, we got to prepare, make sure that we understand that the organization is able to manage the security and privacy risk if it's a privacy issue of like medical. We had HIPAA restrictions. Categorize the system of what it is doing. Select the controls to protect the system. We use the commercial standard, the NIST standard, in order to basically protect, understand the things that we can control and also do risk assessment on. And I don't think we're going to talk too much about that, but anyway, these are the best practices within industry on how to do this, and we conform to this. Implement the controls and document how the controls are deployed and developed. Assess if the stuff is actually doing how it's supposed to do to protect itself, and authorize to make the decision to authorize the system to operate, right? ATO's authorization to operate. And this is a risk-based decision. And then also monitor. So it's like, Professor, I don't understand why we're talking about this in DevSecOps. Let me explain how this all goes about. If we start talking about being able to deliver software quickly, a capability quickly to the user, we have to think about the risk of developing this software and the process in which we're able to give it to them. And it's a risk-based thing. And when we talk about automation, what we're talking about is if we consider this capability that we're developing to be low risk based on the RMF framework model, then we ought to be able to send it without having somebody touch it, right? Without having somebody review it. If it's low risk, we should be able to send that application out to the user and automatically send it out. So when it's ready to be released, it goes out. It doesn't go through another ATO. It doesn't have people manually looking at it if it's low risk. If it's higher risk, if there's higher risk that this is going to cause maybe a cyber problem or whatever, then we make the decision to slow down and stop and then look at this, be very deliberate to make sure that we're not inducing some sort of cyber vulnerability or something else. Okay, so that's the reason I'm talking about this now, is we're using RMF and the DoD to understand and how the best practices on how to protect ourselves in the DevSecOps cycle, the best standard processes and testing for cyber risk. And then when we go into automation, when we want to automate delivery of this stuff, we should understand the risk involved from the user's perspective and being able to make decisions, not just everything stops, right? Today, everything, if you want to release something, it has to go onto the network. You have to have a authorization to put it onto the network, and that makes things slow down tremendously. Remember, we talked about lean and the culture, the things that have to change in order for us to get things out quickly. You gotta make sure that you understand from a risk perspective, cyber risk, and this is our process. So that's what I'm trying to tell you. This is what it looks like. This is their document from the RMF process and has all of the tenets on it. So this is that. So that's what I'm trying to tell you is even though we're able to go fast in the software factory, there's risk involved using from a cyber perspective, and we need to make sure we're following standard practices for cybersecurity, and also we're using the RMF to make sure that we understand the risk and being able to accept certain amounts of risk. That's what I want to talk about. What about this? You must assume the enemy is already inside your system.
So I spoke to this a little bit in my response to the question, and I really think what it does is it puts us in a place where we don't have that soft, chewy center that we talked about earlier in the reading. We kind of build a rigid structure that prevents any further invasion, if you will, of an enemy, right? So if we remain hard on that soft, what used to be the soft center, we can help alleviate the concerns from there.
Yeah. It's been in several DoD documents, and it's been said by leadership. We have to assume that the adversary is already in our systems. They're there. It's like, wow, that seems pretty wide open. It's really, if you assume that the enemy is already in our systems, this changes the way you design your systems. And especially new systems, as we are designing these to be cyber resilient, to be able to operate under an attack. And the design of it changes the way we think. If we start thinking the enemies are already inside, then we start thinking of different models to provide security. One is zero trust. If you already assume that the network is compromised, then trust no one, trust nothing. Trust nothing. It's like, from a design principle, that is trust nothing. Don't trust the system, and don't do it's like, just because you're a user, don't trust the user to have access to another machine or another system, right? You have to build this in. So it has to do with authentication and authorization of the user. as you start going through this, right? And we do this in the DoD. You don't realize how much authentication we actually do, right? Right now I have my CAT card in my my machine, and my CAT card has my authentication and my authorization to go onto some website, some place the data is being stored, right? They're verifying it's me. You see it in the commercial marketplace now. Is every time I try to every time I try to use an app, like YouTube TV is what I have. If I'm somewhere else and I try to log into it, it sends me an alert on my phone saying somebody's trying to get into it. Is it you, right? Or you need it. They're going to text you. You know, it's like prove it's you by verifying this text from your phone, right? They're assuming that two-factor authentication. This is what we're doing. This is to protect and verify that the user is who they say they are. That's really what we're talking about, and that's one way of looking at to mitigate damage and vulnerabilities if the user ID is lost. All right. If we say zero trust, we also need to consider about the architecture in which is going to actually do this. So the zero trust architecture moves away from the perimeter approach, right? Just because I have a decal on my car. Remember, we used to have decals on military vehicles, personal vehicles. Just because I have a decal doesn't let me in through the gate, right? Now I have to show my ID, and they scan the card, and they have a computer that connects back and is verifying. You know, they're moving away from the perimeter approach and assume that we have zero trust in the network itself. The things that you're connected to. Just because I'm on a government computer doesn't let me go to other government websites. I have to use my CAT card to confirm it's me, right? This is how we're building this in. Do you see the multiple layers? We're already doing that. You know, we're starting to learn, but that's not how it was in the past. If we assume that the network's compromised, then we can basically build stronger authentication, and we can follow specific standards that reduce the risk. Okay, so this is the design, the design of the systems. So we're talking about how do we actually build our systems to be cyber resilient? How do we get zero trust principles in? So it's a least privilege access. We've seen this, you know, Snowden. Basically, he was able to escalate his privileges to and get in and hack into systems and get information and download it. We've Manning was another one that if you study this type of stuff, it was because the architectures were not based on the core principles of zero trust architecture, right? We are now assuming that everyone who is going to use the system is an adversary or has been compromised. So we want to limit the spread of this stuff by the architecture of our system. So one of the quiz questions was about rank. You know that you know if you have we trust you if you have a particular rank. Just because I'm an 06 doesn't give me authorization. Even oh my God, it was amazing. From a physical perspective, I had equipment on the Reagan that was in the top secret space. It was actually a system that I worked on prior to getting after getting to the Reagan. But anyway, my equipment's in there. My people go in there. It's TSSCI space for folks that know what that means. And I was like, oh, I need to go in and see what this equipment is because I own it. And they're like, no, you don't get to come in. Even though I had all the tickets, they're like, no, you don't get to come in because you don't have a need to see it. I said, well, it's my equipment. And they're like, yeah. Okay. So that's, you know, that's a principle of zero trust and using multiple layers of security. Okay. So that's sort of what we're designing our systems to today is that's the reason you have to, you know, go, you know, change your password every so often. This is the reason you have to use your CAT card to get into certain things. We're building this in. We've learned our lesson. So if we start by using zero trust architecture as the core principle of our design, it basically limits the the spread of someone being able to get in your system, not able to access other parts of it. So let's just say they get into the email server. They basically are able to get into that system. They are not able to go into the banking system or whatever, right? They're segmented. You got a different set of authorizations, different set of standards to get into it. So how do you do zero trust architecture? This goes basically through the things that you need to do. Verify the user. Is it you? That's called authentication. Yeah, pretty easy. Is it you? Yeah. How does the Apple phone, the new generation of Apple phone, verify that I'm the user? Anybody know?
The Face ID, right?
Face ID. It has a camera. Has a camera on the front. And when I set up the phone, it said move your head all around and everything, and it stored what my face looks like, facial recognition, from all the various angles and stuff. And when I want to authorize, unlock the phone or whatever, when I want to pay using this app at the Navy Exchange, when I do that, it says I need to make sure it's you before you're able to pay for this. So that's what it does. Prior to that, they had a little touchpad and it was a finger recognition, which is sort of secure, but your face, there's no one else that has your face for sure. Josh, you were going to say something?
I was, folks are already covering it.
Okay.
It's going through what you are, what you have, what you know.
Yeah. Oh yeah, it's just like that. So I got an email this morning said there's something changed in your record. You need to log in using your CAT card. I put my CAT card in. I'm there, and they're like, "We need to know this information also." And I was like, "I don't know that information." They're like, "If you don't know that information, click here." And then it said, "I'll send you an email with that information." So I didn't even trust my CAT card. And he's like, "No, I don't even trust you there. I'm gonna go even a layer difference." So at some point it becomes painful to the user, right? We have to do this balance between convenience and of the user and the security of the user, right? We got to sort of weigh that. It's like, Randy's like, when we were talking about storing credit card numbers, it's convenience. I got to verify the device. I got to authenticate that you're actually on the device that you say you're on. So in this particular case, I'm on the NPS network. It's a Navy network, sort of, and it knows that I'm basically, it's me and I'm on this device, authentication. And then authorization. It verifies I should have the privileges that I'm asking for to look at this information. And so that is the steps of zero trust architecture. Verify the user, verify the device, verify that you should have this privilege to use this. Our legacy systems didn't do any of this. We would deliver. I'm guilty of this. Well, I won't call out the name of the system, but we developed a system, and if you were a user of this system, this top secret system, I assumed you were on the ship. You basically knew the password. You were able to get in. Everybody had access to the damn administrative features of the system. They could do anything they wanted. Everybody had the same privilege to do whatever they wanted on this system. As we start thinking about the insider threat or somebody that's compromised and stuff like that, that's pretty dangerous to think that, these people are vetted, they have the right type of clearances and stuff, and they can do whatever they want on the system. Very dangerous. We're slowly bringing those legacy systems back into order. So that's what I wanted to talk about from a cybersecurity perspective. You're gonna ask yourself, it's like, okay, we have all these security professionals. What are they doing? Who are they educating? What's their role in DevSecOps? What's the design architecture we're going after primarily? What type of controls we are building in? It's all this stuff there. That's the reason I didn't take a break, because we're done with this one of the organization which we're going through. So let's talk about the people and the processes of DevSecOps. GAO they're analysts. Okay, if you've ever read a GAO report, they're analysts, and they basically are charged by Congress to look at government stuff. And they look at DoD, they look at other parts of the government, and that's fine. But they have particular tasks on certain things, and this is one of the reports they wrote about our software journey that we're making in the DoD. So this was a November document. There's the listing if you're interested in reading it. It basically said the DoD hasn't really done much from a workforce perspective in developing people and professionals to understand what we're trying to accomplish. One of the things that they said that they were supposed to stand up a DAU course that you could learn about DevSecOps and Agile and everything. They've done that, but you know, how many people have gone through that and why? So if you're trying to modernize your strategy and modernize the way you develop software, you got to train the workforce, the people, so they understand what it is. So maybe a class like this. So if you want to adopt agile methodologies and install new behaviors and a different type of mindset, you basically have to educate these people so they know why we're doing this. And it's a major shift in our organization. This is just a chart that was in the book, but I thought this was interesting as you start talking about making changes in the organization and the number of people that basically are able to adapt and understand how this process works, and the resistance of. So they basically looked at the security personnel. You know, he seems to have a propensity for picking on the security people, but anyway, I think this is of any organization. You get the innovators, the early adopters, and then basically the rest of the organization. So we're sort of probably over here in our DoD acquisition of getting processes going. I think there's 67 programs today that are doing the software process of the adaptive acquisition framework. So they must be doing Agile or DevSecOps. They must be doing some sort of iterative development if you're going to be using that. So 67 out of 3,000 is not a big number, right? This is we got to sort of get it there. But what is it that we're supposed to be doing from our thought leaders? The Defense Science Board in 2018 had a report about DoD software, and they gave us a bunch of recommendations. One is to develop the workforce so they're competent and familiar with current software development techniques. You're probably familiar right now with the software techniques based on the third week of education. Military departments should acquire and access a small cadre of software system architects with a deep understanding of iterative development. We got to get the technically competent government people and retain these people that they're able to lead us through and understand how to set these things up. What was happening was, what do you want to be when you grow up in the government? Okay, I want to be a program manager. All right. If you're a technical person who is working on software, a software architect, what do you want to be when you grow up? And they're like, I want to be what I am now. Well, there's no place for you in the DoD. You got to be a system engineer, or you got to be a program manager or a contract manager or a financial manager. Right? You don't fit in these square pegs. Round hole and square peg. I like one of those. And these people just got sort of left aside. They weren't getting promoted, and they just quit. It's like, I can go in industry and do this stuff, right? And that was a big bleed out of competent people not having a promotion potential to continue in leadership. We sort of fixed that. So you see some people, if you're in an organization like this, you'll see people with a title, and you're like, what is that? That's who they are. They're the smart people we're trying to keep that understand all this stuff. So that's what they're talking about, in case you were wondering. And so we should be using these people of people to understand the acquisition process, formulate the strategy, develop the source selection criteria, and evaluate the progress that we're making. So we need people that are smart in acquisition too, believe it or not. Develop a training curriculum. This is what they were talking about, that includes software acquisition training and making sure program managers of software intensive programs know that they're actually working on a software program. I was involved in 3 programs that I thought were hardware programs, and they were actually software programs. But I managed them like hardware. Okay, bad. My last one was the biggest software-defined radio program in the DoD history was my program, and I was treating it like a hardware program. They were too. They set it up to fail. But anyway, that's neither here nor there. So DAU, like they said, hire people that are smart from across the military and industry, and create a iterative development team. Basically, understand this associated with training. So go get the people trained. Next year, the Defense Innovation Board basically wrote some recommendations here. They were basically saying the same, sort of similar to the same thing, making sure that we understand the civilian people and the military people understand how to develop using modern practices, and they call out DevSecOps in particular. Expand it for leadership, the training for leadership. The PEO has to understand this, the 1-star, the 2-star, the SES, they got to understand why we're doing this so we can start breaking the culture resistance, right? If everybody sort of agrees this is the right thing to do, then it's a lot easier to get into this. So that's sort of where they're going with this. So they wrote a report about the reform efforts within the DoD, of course, and they said, hey, let's see how you're doing. They basically said, we're going to track this stuff, and here's our report on this involving the status of the reforms that we just talked about, where they're going. They know this is going to take some time for us to change, but people are the most important part. If we don't educate and train the people and the leadership, we're never going to affect this culture and drive performance and everything. So that's sort of where they were as they look there.